Okay, now part 3 of lesson 8. So we're gonna review Enterprise Manager for RAC database monitoring. And you can monitor RAC database activities directly from Enterprise Manager Cloud Control. So we're gonna see a few graphical information to understand better. Okay, so here we have a cluster database performance page. And here we have a cluster host load average per core. And also we have a global cache block access latency and average active sessions. So there are a couple of pages, a couple of graphs here. So I'm going to actually use a class node to give you explanation of each graphical information. Next page here. So this is the screenshot of a cluster host load average example. Okay. So this example is per core, the cluster host load average per core. The rule of thumb, when you look at Oracle support node, one core, as long as one core can handle 2 to 4 runnable processes, and that's more than enough. But for the long time period, if one core must handle greater than 4 processes constantly, then that's what you have to take a look at. So maybe CPU bottleneck, and also you may have to add more resources. So in this particular example, I can see 8:30 to 8:40, and this is a peak time according to this graph itself. And just for a short amount of time, we observed a runnable processes per core greater than 4, but it's only for a short amount of time. So to me, this is acceptable. But if you have the runnable processes a high spike like this constantly, then this will be this will be CPU the resource contention related issue. So you will have to add more power, or you have to tune your SQL or your system. You have to wait to find out to control the load average. Actually, this is typo though. And then let's take a look at next one. And the other one is global cache block access latency. And we had a discussion on this area. And this example, we have average current block access receive time and consistent read block receive time. According to chart through the one of a slide, upper bound of a consistent read block receive time was 12 milliseconds, and also upper bound of current block receive time was 30 milliseconds maximum. So if you constantly observe beyond this number, that will be one good opportunity to tune your system by looking at this area. And in this particular example, the peak time is around 9. And as you can see, at this time, I only see 20 milliseconds, but only very short amount of time. So average current block receive time during the peak time, it was 20 milliseconds. So it's still lower than the upper bound of a typical latency. So it is acceptable. So let's come back. Now I reviewed this. Now let's take a look at average active sessions. Okay, so this average active session graph doesn't give you much of information here. So what I'm going to do, I copied the better graph from the one of a slide. So how can I interpret this? Okay, so one thing what you have to know is this: the graph color order here is the same as this order, and also statistics is a cumulative. And the other one here is this is your database activity. And your database activity divided into two sections. one is wait, and the other one is the CPU. And total is database activity. If you remember, average active session is directly related to your DB time. So by looking at this graph, you should be able to understand your database activities. And according to this, during the peak time around 1240, we observed around 6.5 average active sessions. So meaning that 6 sessions were a little over 6 sessions did certain operations in this time period. And just to make simple, let's say this time this was our peak time period and problem time period. So how do you interpret this graph? Okay, so you can easily interpret this graph in this way. We have green color here, and light green and green color, and the spike is around 1. So in this peak time period, out of 6.5 average active sessions, one session was consuming, one session consumed the CPU time in this time period. And also, another statistics is a blue color. So what is a blue color? That's huge I/O. So the spike is here 4.3, 4.0. And 4.0 include 1.0 as well. So the difference is actual statistics, meaning that three average active sessions, three average active sessions waited for disk I/O completion in this time period. And also, we have a brown color here. The spike point is 5.5, and then it includes all these cumulative statistics. So difference is the actual value. So 1.5 average active sessions, okay, I believe this is a concurrency waiting for resource in memory, possibly as a part of the concurrency control. And also we have other. So which means that if this were a real problem time period, and you will have to focus on this I/O area. So you can click this I/O or user I/O link to get into more details. And even though this number is very small, let's say you make this number higher. So if this example were 10 average active sessions, 20, 30, 40, 50, 60, 70, then it's easier to understand. Okay, in the practice environment, this was actually the example, but you can actually make it more realistic, making this an average active session higher, and you can easily understand in this way. And also, by clicking CPU link, you can also see whether CPU statistics or CPU activity is CPU activities mostly from one of the instances, or CPU activities balanced across instances. And also we have a database throughput. And in this example, you can actually check how many transactions can be served by your system. And in this example, transaction is nearly 0. That means looks like this system is an idle system. And also you can get redo generation rate. In this particular example, 60 kilobytes per second. So this is an example of a throughput information, most likely from idle system. And I explained this graph. I copied this example to explain just right before. And also you see that whether all these activities from multiple instances, or whether we have these activities from one of the instances. Looks like in this example, mostly we observed this pattern of activities from one of the instances. So if this is an example, then you will have to look at one of the instances to see if you can find out any tuning opportunity. And also global cache block access latency. I already explained it. and also global cache block transfer rate. So let's get into this area. Okay, so in this example, this graph is showing you number of blocks per second. So how many blocks transferred per second? So assuming that your interconnect network is a 1 gigabit network, that means theoretically we can achieve 120 megabytes per second throughput. Okay, definitely practically this will be less. So do we have enough network bandwidth to support current traffic? So if this is your embodiment statistics, and we can get this information. So let's say from 0 up to 10. So in this peak time, we observed 10 block transfer per second. So if your block size is 8K, and we transfer the 10 blocks, that means in this given time, we observed 80K data transfer per second, because we only deliver the 10 blocks. And out of that, global cache current block transfer is a 9 block, so 72 kilobytes per second. And also 8K data is transferred for consistent read block delivery. So according to this, your interconnect network is more than enough. So it's not a big problem in this case. So you can interpret this way. So as you can see, the unit here is a blocks per second. Now we're going to take a look at the other area. So here we have a global cache, block transfer, and physical read. So what is the meaning of this? So unit is a percentage. So what is the meaning? So this is to understand total I/O distribution in RAC environment. So in this example, I just made it in a simple example. I have blue collar statistics around 55% range. So that's a physical read. And also green color, I just made it simple, 60%. So difference is 5%. So how can I interpret this? And 5% green color is a global cache block transfer. So the idea is this. Assuming that you have 100% disk I/O distribution. Okay? Out of 100%, the 55% is, in this case, physical read. So from here, over 50%, so in this case, 55% of I/O, total I/O, that is a disk I/O. That's an indication. And then we have a 5% here. The 5% is global cache I/O. Okay? And meaning that 40% is something else. So what is 40%? The idea is this. If you have a 2-node cluster, for example, this case, and you have actually a disk, and then from one of the instance point of view, out of 100% of total I/O, we were able to read 55% of I/Os from physical disk. Okay? And the 5% through global cache activity, meaning that from remote instance. And then 40% is we were able to read 40% of I/Os directly from the local instance. That's the meaning of this. So what is the rule of thumb? Whenever possible, I want to make more logical I/Os, and especially from local instance. So in this case, you will have to find a way to reduce physical I/O, and when possible, make more I/Os from local instance. So you can get this kind of information from here. And I explained cluster cache coherency information. And also you can review database log pages. So you may have the blocking session across instances from database log page, and you can easily identify blocker and session that is blocked. And also you can run AWR report to understand each instance activity, or you can also use the same report to understand cluster level activities. So in the main report page, you will see many of statistics that are directly related to the global level activity statistics. And you can also use active session history. So if you want to analyze short-term database activity, you can use active session history, and this gives you more detailed information if you are interested in short-term time period activities. And before you analyze AWR report or ASH report, you may want to use ADDM, because ADDM has a capability to understand your database, database activities through statistics. And ADDM, it uses the same tuning strategy what we used to use, which is DB time based tuning. ADDM can analyze entire cluster or specific instance or subset of a database instance, and eventually it can make recommendations and also findings. So you can identify most critical performance problem and the component that are eating up large amount of a DB time, and that will give you the best and optimal tuning opportunity. So you can actually check findings based on priority. And also database-wide analysis of a global resource, high load SQL and hot blocks, and all these are available. And these are also what ADDM can detect: latency problem, congestion, contention, top consumer, lost block, and also some other information as well. And you can check ADDM findings from Enterprise Manager. The latest report is available from diagnostic section in the home page. And in this example, 8 findings detected. So you can actually review one by one to get detail. And also, if you are using Enterprise Manager Express and on the Performance Hub page, you also can use ADDM as well. So it will give you similar information. And the other one is, you can also monitor RAC database with a cluster health advisor. Okay? So what is a cluster health advisor? This is new in 12.2. And you will see this in a new structure. Database level, we always can collect the active session history information. Okay, this will be a good source of cluster the health advisor, and also at the OS level, cluster health monitor OS metrics also can be a good source of cluster health advisor. What it does, cluster health advisor, it continuously collected statistics from OS level, from database level, and then compare with predefined the common problems. Okay, if a statistics collected from database or at the OS level, it falls into predefined database problems or OS level problems, then cluster health advisor, it can make a recommendation. So what are the findings, and what we should do to resolve this problem? So it's kind of a machine learning stuff. So our develop team already coded to detect the most common database level problems and OS level problems, and then compare with the statistics. So if something goes bad, then it can make recommendation directly. And when you attend the cluster-aware training, and this practice and the more detailed information will be available. We can just run this command, CHA-CTL monitor database, to enable cluster health advisor monitoring, and you can also disable, and you can also check status. Okay, so we have a quiz here. Although there are specific tuning areas for RAC, such as instance recovery and interconnect traffic, you get most benefit by tuning your system like a single instance system. I agree with this. So the answer is A. And which of the following RAC tuning tips are correct? Item A, application tuning is often the most beneficial. I agree. And reduce long full table scan in OLTP system. I agree. And use partitioning to reduce inter-instance traffic. I agree. Configure the interconnect properly. I agree. But C, eliminate sequence cache. I don't agree. Sometimes sequence with the cache option can resolve index level contention. So the answer is A and B and D and E. In this lesson, we split the lesson into 3 different sections. The first thing was introduction, and second part was tuning tips, and third part was a monitoring topic. So we discussed a good amount of topics from lesson 8, and this is for lesson 8.